Okay, so today we are going to see EIGRP, Enhanced Interior Gateway Routing Protocol. What is EIGRP? Similar like OSPF that we saw yesterday. For two devices to exchange their routes, you can use any routing protocol. We used earlier RIP, then we used OSPF. Now we are going to use EIGRP. EIGRP was Cisco's proprietary. I mean to say it was previously Cisco proprietary. They have kept it open now. They released the codes, it seems, last year back. In Cisco Live London, they declared that we are giving away this protocol. So any other vendor, if this was Cisco proprietary, means it used to work only on Cisco routers and switches. But now if I say it is open standard, it will be working on all the other vendors also. This again, like OSPF, EIGRP also uses multicast. Okay, so RIP, you can say, works on the application layer, but EIGRP has its own protocol. It sits above the IP header. Now, EIGRP is a little different. We also call it hybrid routing protocol or advanced distance vector routing protocol. Why? Because it uses both the things. OSPF understands the link bandwidth, but EIGRP understands 5 values, you can say: bandwidth, load, delay, reliability, and maximum transmission unit. These values are known as K values. So EIGRP can understand the bandwidth on a link and how much is the link being used, what is the load on that link, how much time will it take for a packet to reach and come back, you can say smooth round trip timer, and how reliable is the link, how many times the flap has happened, and how heavy can the data be, you can say. Maximum transmission unit is usually 1500. So by default, EIGRP is tuned to use bandwidth and delay. Bandwidth means it will consider the least bandwidth of the path. So if I say I have two routers over here, sorry, if I say I have two routers over here, one
least bandwidth means more speed, right?
Least means very less. I'll tell you that. So if I say here I have 1 GB speed, here I have 10 MB speed. So it considers the 10 MB, it considers the least bandwidth. Least bandwidth and the cumulative delay. Cumulative delay means delay from me to this, and if there is a network behind this, the total delay will be calculated. So it considers the worst case scenario, you can say. This considers the least bandwidth on the link and also considers the delay. Delay means cumulative overall delay, you can say. EIGRP uses 3 tables. OSPF had a topology table. On that topology table, it used to run an algorithm called the shortest path first algorithm, written by Dijkstra. But this protocol keeps 3 routing tables. RIP used to keep the whole routing table of the neighbor, right? This guy does the same. It keeps the topology of the neighbor, you can say. Then it creates the topology. Topology means it will build the roadmap. If you and me are both routers, we both will have our own networks. So I will take your whole routing table and I will build a roadmap. And on that roadmap, I will use some calculations and find out the best path. And this best path will be kept in the routing table. Now, EIGRP is better than the other protocol if you say. Why? Because EIGRP has sub-second failovers. Why sub-second? Because if I have a best route, this route goes down. The second best is already calculated and kept in the topology table. The best route is called successor route. Now, which algorithm does this EIGRP uses? EIGRP uses RTP, Reliable Transport Protocol for Communication, and it uses dual diffusing update algorithm. In diffusing update algorithm, it will use the bandwidth and the cumulative delay and calculate the best path. Now, technically, there are 5 K values that are in CCNA for us to understand, but the moment I show you the packets, there will be a 6th K value also. That will be the hop count. So EIGRP is better if you compare from the other routing protocols. Why? Because it understands many things, but by default it is tuned to understand the bandwidth and delay of the link. And EIGRP uses its own protocol. RTP has two acronyms actually. RTP is real-time protocol that is used in voice, and reliable transport protocol is for EIGRP. So EIGRP sends hellos. Yesterday we saw that hello packet is kept sent to check whether the neighbor is alive, right? So hellos, updates, queries, replies, and acknowledgement. So it uses multicast and unicast both for communication. If you remember from yesterday, we saw that OSPF has two types of routes. Actually, we saw three types of routes in OSPF. OSPF has one route termed as OSPF intra-area, OSPF inter-area, IA, and OE2. Yesterday, we saw three types of routes. This was OSPF intra-area received from the same area, and this was from another area, and this was from another autonomous system. We saw three types, right? But the administrative distance of all these three is 110 only. In EIGRP, if a route comes from another you can say routing protocol that is redistributed like yesterday, it will have an AD of 170. If you have an internal EIGRP route, then it has an administrative distance of 90. But the others will have AD of 170. So two administrative distances for EIGRP. Okay, so assuming a scenario wherein you and me are routers, if we want to form neighborship, we must have some parameters that are required. So what will be the very basic parameters? The very basic parameter, first of all, should be your and my IP address must match. So your and my IP address must match over here. So we should be in the same IP address. We must be in the same autonomous system, AS. OSPF uses areas, right? EIGRP uses autonomous systems. How many autonomous systems can you create? 65,535, 65535. And EIGRP. Now, what they say is you should have how many routers in one autonomous system? If you say in one autonomous system, they say you should have around 100 routers. That is actually, it is the hop count that EIGRP supports. EIGRP can support up to 255 hop counts, but by default, it is enabled for 100. You can say the default hop count is 100, but EIGRP can support 255 hops. So if I say I have one autonomous system, and in one autonomous system, I can keep 100 routers. So if I say I have capability of 65,535, how many autonomous systems, how many routers can I have? This will be into 100 per AS. So it can have 6553500. So many routers you can support in EIGRP. It is a very nice routing protocol, very fast, you can say, and very intelligent routing protocol. So one autonomous system can have 100 routers, actually 255, but worst, least if you see 100 routers, and 65 AS is like this, then you can say so many routers. But we won't be implementing so many because we are in CCNA as of now, and we are talking about a small to medium enterprise network. Implementing is very easy, very simple, you can say. So just understand one thing, that if you give me a route, I will take your routing table, I will create my own roadmap, and I will calculate the best path from me to the network. That best path will be called as the successor. So the successor is who? It is the best route to the destination network, and that will be stored in the routing table. So if I get a best route, that is the successor route, and the second best is kept in the topology table. In EIGRP, assuming a scenario wherein you say you stay near the airport, and from your home, airport is like 1 kilometer, for example. This is you, and this is me, and this is me. You say, okay, from me to reach the airport, it takes 1 kilometer. And so you say, okay, airport is 1 kilometer far from my home. What is this? This is called advertised distance or the reported distance. Means this is me. You have advertised this distance to me, saying that airport is 1 kilometer away from your place. But from me to reach your place, it is 10 kilometers. So my total distance to reach the airport will be 11 kilometers, right? This is called as the feasible distance. So the distance that has been told to me from my neighbor is the advertised distance. You tell me, you advertise it to me, and from me to reach the actual network, the feasible distance is this one, right? Now, there is also one criteria of the feasible successor. It says that whose reported distance must be less than the feasible distance. And yeah, this is actually a loop prevention mechanism. If I tell you how far is the airport, you should not say it is 11. If he asks me that how far is the airport, I will tell him it is 11. So he will not consider my route as a backup route because he has a shorter path, right? If I tell him I know the airport and that airport is 8 kind of me, then it will choose to accept it. But that is a different scenario. We'll see that later on. But this is what the feasible successors criteria is, whose reported distance is less than. So if I have a better path, then I will choose it, whose reported distance is less than the feasible distance, and that will be considered as a backup route. Now EIGRP is the only protocol, as far as I know, is the one who can do unequal cost path load balancing. What do I mean to say by that? Means if I say I have 2 routes, if I have 2 routes from here to the network, from here to here, and this route is like 1 GB, and this is like 512 MBs. If I say that, so EIGRP is capable of load balancing in this kind of a scenario also. That is done by using something called variance multiplier, you can say. In variance, what you say is by default it will use the equal cost path only, but if you want this backup path to be considered, you will tell the router, if you see a path that is half, then you will multiply this by 2. So it will understand, okay, but actually this is total is 2 GB, so you have to say variance multiplier 4. This, if 512, 2 GB divided by 4 will be 512, so then this would be considered. So by using variance, you can say that use this path also. And EIGRP is the one that can do that. OSPF will not do unequal cost path. If OSPF has the same path, then he will use this path also and this path also. But EIGRP, but OSPF will not use this path if the link speed is less. But EIGRP by default will not support, but if you say, I want you to take this path, it is also capable of doing that. Okay, so let's see the calculation of the metric later on, no worries. Implementing it is again very simple, and by default EIGRP uses the bandwidth and delay. For 2 routers to be neighbors, they must be a part of the same autonomous system, same area, same area means same autonomous system, you can say. So if you and me want to form neighborship, we both must have the same IP address segment, we both must be in the same autonomous system, we both must have the same K values. If you say my calculation is bandwidth and delay, this is using bandwidth and delay. If I say the metric cost, and you say I am using the bandwidth and load, this is what I am not using, so this will not form neighborship. In OSPF, the hello time, hello and dead time, hello and hold time must match. In OSPF, right? If you and me have a different hello time in OSPF, in EIGRP it is not mandatory. In OSPF, your and my hello time must be same. In EIGRP, if your and my hello time is and dead time is different, it's not going to affect anything. Let us start. And let us see what is the behavior of this one? The routers are booting up. Let the routers come up. So we have two routers over here. And what should be the configuration? Configure terminal interface fast Ethernet 0/0 IP address 10.0.12.1 255.255.255.0. No, shut it down. And how will you start the protocol? You can say router EIGRP 1. Yesterday we saw OSPF 1 was the process ID. Here this one is the autonomous system number. This one on R1 and this one on R2 must be the same. And here I will say network 10.0.12.0. You can do this one also, and if you want you can specify the wildcard mask also same, but EIGRP will understand this automatically. And you have to say, let us see auto summarization later on. Let us just form neighborship and see what are the parameters that R1 and R2 are using. So why did I take 10, 1, 12? Because between R1 and R2, it is 12 network. Simple to understand. So let us copy this and let us paste it on the router R1. And let us paste the other config on router 2. It will be 12.2 and rest all is same. Autonomous system should be same. If I by mistakenly, if I say this, it will, the neighborship will not come up. Let us do that. The moment I say no shutdown, it will give me two pop-ups. Yes, layer 1 and layer 2 status is up and waiting for adjacency diffusing update algorithm. So if I say show IP route, it will not come up in the routing table. Why? Because by default, the connected route has the AD of 0, static has 1, EIGRP has 90. As of now, these both show IP, EIGRP, neighbors. It says I have this handle call. This is the serial number if you want to compare it like that. This is the IP address of the neighbor. Interface, uptime, smooth round trip timer, and sequence number is 3. So we have formed neighborship with this person over here. Show IP, EIGRP, interfaces. I will tell you this is the interface that I am running EIGRP on. And if you want to say show IP, protocols, this is a very nice command. See, in show IP protocols, it tells me that this is my autonomous system number. This is very important when it comes to troubleshooting. So show IP protocols will tell me which protocols are running. And here if you notice, EIGRP metric weight is K1, K2, K3, K4 and K5. The maximum hop count is 100. Variance by default is 1. And maximum paths are 4. This is your network statement and this is your administrative distance. So now you see that I have a neighbor over here. Now if you see I have a neighbor over here, that is 12.1. But if I want to have some trouble, what I will say is I want to tune these calculations. How do you change the metric calculation of EIGRP? You can simply go into the routing protocol router EIGRP1 and you can say metric weight. If I say metric weight, hit a question mark. This is type of service. You can say layer 3. This will be 0 only. Don't worry about this. But here now it says what should be the K value. If you say what is the bandwidth load delay, I'll just change it bandwidth a little bit. I'll change. So now if I check, see here it says neighbor went down. Why? Because the K values are mismatching. His and my metric calculation terms are not matching. See, it will come up. And if I say no logging console, the console log will be disabled. You will not be able to see these pop-ups from now on because I told him, please do not give me any console messages. So for you to troubleshoot, if you don't see this error, how will you troubleshoot? You can say do show IP protocols. In your IP protocols, here it tells you that I am using bandwidth and load delay I am not using. So this value and that value is not going to match and the neighborship will flap. Okay. So let's go and change it again. Router EIGRP1 metric wait, type of service is 0, bandwidth, load, delay, reliability, MTU. This means I want to use this. So I want to use bandwidth and delay for the metric calculation. And if I say exit logging console, then the console messages should come up. Actually, the neighborship must have formed. Show IP EIGRP neighbors. I have formed neighborship over here. Let us see one more small thing. Let us see in here. Let us capture the packets and let us see what is it doing in the backend. So this is our EIGRP hello packet. I'll simply stop this one. Just go and stop this one. Stop the caption. We want to see here what is inside. See, this uses 224.0.0.10. And this, if you want to open a packet, you can open the hello packet. Inside this hello packet, this is your layer 2 frame, layer 3 and EIGRP's packet. So if you see source and destination multicast, this is the destination IPv4 multicast for this number 01005E 00000A. A means 10, isn't it? Yes. So let us see what is in the IP packet. In the IP packet, the time to live is 2, source is this, destination is this, and in the EIGRP, Cisco EIGRP, this is a hello packet. This is my autonomous system number. These are my parameters. You can say the whole time is 15, but here I told you that EIGRP uses 5K values, but in here it has one more 6K value. Okay, so seeing here, EIGRP uses 5K values and the sixth, what is this 6K value? This is technically the hop count. But for us in CCNA, we just need to understand that there are 5K values: bandwidth, load, delay, reliability, and MTU. And by default, the bandwidth and delay is used. We can also tune these timers if you want. And this is important for us to understand. Wireshark, you should take out time and read the hello packets. This will be your layer 2 source IP, destination IP. This is layer 3 IP packet. See, EIGRP has its own protocol. It sits above the, besides the IP header, you can say.